and they're going, you first, you know, try him first. You first. I'll wait. You know, it's okay. So the three sort of principals of that group are Silvio Micali, Ron Rivest, and Shafi Goldwasser. So in another presentation, this was one of the only ones that the actual directors gave a presentation. And Silvio Micali, to illustrate a particular point in cryptography, did a magic trick with cards.
Yeah, that must have been fun.
Yeah, it was pretty good, I thought. I like magic tricks anyway, so you know, it doesn't matter what it is. If you do a magic trick, I'm impressed.
Our meeting time is listed on the calendar as 7:30 p.m. to 9:30 p.m.
Uh-huh.
I was actually thinking to change that to 7:30 p.m. to 10 p.m. I'm not sure if I should do that retroactively for this meeting, or start next month, or start for January.
Well, the ones that usually started at 7:30, when did they finally end? Before 10 o'clock, right?
I used to list it as being from 6:30 to
Right,
9.
right. But haven't there been a few that have started at 7:30 already? I wasn't here for the last one.
I think the first one we did for that, well, I have to look at the website. Probably a couple months ago, probably the one in August.
Yeah.
I'm not sure about July, I'd have to check that. I'm busy with this other thing first. Let's see.
Well, if it lasts till 10, I might have to bail a little bit early. I don't want to miss the commuter rail train. Of course, if I miss it, there's always the 12 a.m. bus that leaves Ashmont Station, but I'm not too happy about taking that one.
At least you don't have to worry about being stranded. I was actually wondering what we'd do if the MIT parking decided to tow Jerry's car.
Oh, he's in the E51 lot?
Yeah.
No, you can't do that. I got a ticket.
When, last time?
No, this was like months ago when they first started to do it. I was out there with a bunch of people on a Saturday, I think it was, and they gave us all tickets. It was like $30.
I have the shell script and I just use them.
They don't tow you.
Jerry, Ben says he got a ticket parking here a couple weeks ago, was it?
No, it was a few months ago.
A few months
when
ago.
they first started to do the restrict the E51 lot.
I'm going to risk it tonight, but yeah, they probably could.
The worst that could happen is you get a ticket. They won't tell you that.
Yeah, I don't. They would have to get a flatbed. They can't put my car on a regular tow truck. There's no way to do it.
Oh, what prevents it?
It doesn't have.
There's no hooks.
There's no frame to hook onto.
That doesn't mean they wouldn't try.
Well,
I just said.
And I suspect. Well, I don't know for certain.
Yeah, the worst that would happen is they puncture one of the batteries and the car would be ruined.
Yeah.
You don't want that to happen.
Yes. Yes, and the question is, do you have comprehensive insurance which will pay to replace it?
Which I do.
Oh, okay.
Well, but if it's your fault that you parked in a place you shouldn't have been, maybe the insurance.
No, it's their fault because they ruined the car.
Yeah.
They didn't use the right equipment.
I mean, they're supposed to know how to handle it properly.
Yep.
Like, what if you have a club on the car? and you're in a parking space, they have to like,
They have wheels.
you know,
They jack it up, they put these wheels under, and then they can pull
pull the car up sideways if you're in a parking space, you have someone in front of you, someone in back of you.
Yep.
Okay, well, I guess that blows my mind.
But they need a flatbed for my car.
I also, my one worry, one sort of worry with that is whether, I suspect they've probably got some sort of thing in the law saying that if they damage your car while towing it, sorry, that's your fault, not ours. Although, as long as your insurance doesn't have something in there saying that we don't cover damage during towing, you should be, your insurance will then have to cover it.
Well, they can't do that because you never, but if they damage your car in towing, generally you can make a claim, and they have insurance,
Yeah.
required by law anyway.
AAA once towed me back home, and they have to like turn to put me in the driveway.
Yep.
So when they turned, the front of the car was, you know, on the hook
Yep.
behind the truck. So when they turned, they broke one of my, not the headlight, but the
Yep.
light underneath. And I didn't know this. So when I came out the next morning and I saw the broken plastic on the road, and oh great, they broke one. And I called and they said, oh, that was there already. The pieces in the street. And I took a picture of the pieces in the street. And
They'll say it.
yeah, but
You
I
need
mean,
to-
it was bogus. They couldn't get anywhere with that claim. Oh, it was already broken. The pieces were there in the street. They were the same color as the rest of the
You need to
thing.
sue them in small claims court.
I didn't have to. I just called AAA and they took care of it.
Yeah.
It's weird.
Yeah.
Current issues in SSL and TLS. They were either designed by committee or they were designed by companies trying to make money, and therefore they're highly complex and not really designed for, they're designed to make money for corporations that can say, here, pay massive amounts of money for our implementation of this complex protocol.
You mean the implementation hasn't been verified to be good? Hasn't been certified to be proper?
Well,
True according to specification?
hopefully Bill is going to be there tonight, and we're going to have an active discussion after the meeting.
Yeah.
But I remember when they started talking about cryptography, the MIT crypto people were pushing to get, RSA encryption or GPG encryption used for this.
So what is actually used?
Well, SSL and TLS.
No, but I mean the encryption mechanism.
I'm not sure what they're using now. They were for a while using DES.
Well, that's no good anymore.
I know.
Yeah. At least for a while, they were in fact using RSA in there, which is what's used by PGP.
Looks like we're in good shape.
Many a year back, they were claiming, hey, this stuff is kind of slow. We don't want to bother implementing it. And more recently, it's pretty well been shown that no, it's okay if you're on a server and you're doing lots of transactions. Yes, there is substantial overhead, but it's not that expensive.
Well, if you're going to use GPG as your encryption method. You use GPG to exchange keys,
Yes.
and you use shorter two-way keys.
Yeah. Meanwhile, SSL and TLS are very much certificate-based, where
Yeah.
you're supposed to get an authority to sign them, and well, this does sort of work as long as you can trust your certificate agency, and well, you really can't.
Even the well-known ones?
Well, any ones that are well-known, if a government agency tells them, sign this certificate, generally what they will say is, yes, sir.
And they sign it so that the government can unlock whatever it is that they want to?
Well, usually if the government says, sure,
Yeah.
or usually if the government says, please sign this certificate, generally such entities will say, sure. At least to the government of which they exist in, of the country which they exist in.
Yeah.
Other governments, they may not say sure, but and the other issue is that the browsers will usually know all of those, thus an appropriate government will merely say, we need to search for this domain, and generally they simply find their local agencies, at which point, well, they will man in the middle whomever they want, if they so desire.
Apparently, Trump sent a $25,000 check to a soldier that was killed in Afghanistan.
Now the question is, will the family cash it, or will they return it?
Actually, my first question would be a little different than that. I'd ask, is he actually saying that to the family, or is he just claiming that but actually keeping himself?
Oh, that would be evil. I don't think would he do that?
He does that all the time.
Yes, he might.
That's not right.
If it was a personal check, which I think it was. But
Well, he could also write it against an account where the balance is
Yeah, I
zero.
think even if it's a personal check, all we really have is his
but
claim that it's a
eventually
personal
the
check.
fact that it bounced or didn't work right would get out, and he just looks stupid.
But it's really stupid.
Is there any verification this happened other than Trump claiming it happened? Because he is a
Yeah.
pathological liar.
Verification happened, but the issue is he did it to one soldier.
Yeah, there are lots of others.
What about the others? What about the ones that were killed in Niger?
Yeah.
Yeah.
The one he outed yesterday. Well, the guy knew what he was getting into. I mean, that would have been true if I were killed in Vietnam too, because I wasn't conscripted. I would fly Huey over there. And if I had gotten shot down, or if I crashed, a lot
Back to
more
the minute.
danger flying a helicopter in Vietnam than just getting shot down.
Yeah, there's also the issue of what if parts fail?
Well, you're doing maintenance out in the field.
Yep.
Helicopters have a large number of parts. Parts are usually time replacement. There is a tremendous amount of vibration in a helicopter, which weakens the metals.
I'm pretty sure it doesn't weaken the metals. It's just a case of it elevates metal fatigue.
Well, yeah.
Same thing.
Exactly. helicopter, or most aircraft, bolts, when you tighten the bolt, there's usually a hole in the screw at the very end, and you put wire, either a cotter pin or wire through that to make sure the bolt doesn't come off. Depending on the type of stuff, it's usually a cotter pin, but it's, when I used to pre-flight aircraft, I could pre-flight an aircraft in the dark, and that's one of the things I look for is those bolts and see if they have the cotter pins. You can just feel for them. I learned how to pre-flight an aircraft in the dark.
I suspect if you do it during the day, it's best to use your fingers anyway, because that just is sort of a reminder to check that, yes, the pin is there.
Best way to pre-flight an aircraft is to do it by the book.
That I can well believe. Because even though some of those things are mind-numbingly boring and stupid, yes, those things are there because those are the parts that fail.
In flight school, we had a checklist. And if we did not, in primary flight school, we had a checklist. If we failed to use that checklist at any place where the checklist was supposed to be used, you get a pink slip. In advanced flight school, you were not allowed to use a checklist. You had to have it memorized. Because out in the field, you may not have the checklists.
How long is the checklist?
It's about 30.
30 pages or 30 items?
30 items.
Oh, that's not bad.
No, it's usually it's a laminated piece of plastic.
Yeah.
They're not very much, but like you're starting the aircraft and stuff like that. Like one of the things in a naturally aspirated aircraft, when you take off, you have the carburetor heat full on because of the who's that Italian that I'm trying to remember the thing. And essentially, when air goes into the carburetor, it expands and it carburetors.
Bernoulli?
Bernoulli, yeah.
Oh, okay.
Carburetor works in the Bernoulli, and because of Bernoulli, well, so does an aircraft. Aircraft flies basically based on Bernoulli's principle.
But which one was it? Because there were a bunch of them. There were at least two.
Bernoulli?
The Bernoulli brothers. Oh, yeah.
Oh, didn't know that.
Yeah.
But in any case,
I can't tell one from the other.
any case, your carburetor will, at full speed, you know, at full power, is going to run cold, and in certain air conditions, it can freeze up, and you don't want it to freeze up on takeoff. And then on when you get up to level flight, you turn the carburetor heat off, unless you have weather conditions where you might need it. And you can feel the engines start sputtering a little bit. You can just throw on a carburetor heat. But not straight level flight in normal weather conditions, it's not really necessary. In a helicopter, you're a turbine aircraft, so that's a little bit different. There's no such thing as a helicopter that can fly. Any good
Pretty small
engineer
turnout
can
so
do
far.
There's no such thing as a helicopter that can fly.
Every good engineer can prove a helicopter can't possibly fly.
Well, then there must be something wrong with the proof.
No, that sheep falling to the ground and then missing. Hey, Dude.
How you doing?
They can prove with a beam because
Yeah, exactly.
but they're flying around.
Right, Chief, I'm using the HDMI, so feel free to just plug it into your computer.
Great.
By the way, do you have any time constraints? I think we originally listed the meetings running to 9:30, but we were talking about extending it to 10 o'clock.
No, I can go for the kids are already gonna be asleep by then, hopefully, so it should be fine. Although last time when I gave this talk here in January, it was just an hour, but the audience didn't ask questions, and I think this audience will. So.
Well, it depends who's here.
Fair enough.
If Bill Ricker gets here, you're up for an awful lot of discussion.
Well, he came in January
Okay.
when I gave it, and he was the one who reached out to Jabber and said I should
Because he
do
posted
it here.
He posted on the listserv something about WPA2 issues.
Yeah.
Oh, yeah.
Yeah.
And we're still figuring out how to cope with the parking restrictions.
Elliot always asks questions.
So why don't I hook up and make sure everything's okay.
Elliot's never shy.
That's right. All right. What do we got? So we have your HDMI, but it seems that there's another input, so maybe I'll just use that. Just switch inputs. 'Cause this
Bill
is,
wants.
yeah.
Is that through VGA?
It's VGA and then we'll look into this. So
Okay.
that'll work. I haven't seen this. They've been upgrading. When did they put this one in?
It's been in for a while.
Yeah, so whatever classrooms I use over in the main campus doesn't
Okay.
have this setup, but it's probably this.
Yeah, this, we have the two screens, that, and we have that screen over there.
Oh, nice. That's new too.
So we can possibly switch yours once you get your system plugged in and out.
Yeah.
We'll see if it.
Jabber, I don't think it's very useful to have a pencil that's not sharpened.
I never saw the point in removing it from the thing.
If anybody can read my handwriting.
Have you sent?
Okay. Okay, just update October, November, December to end at 10 o'clock instead of 9:30.
That's good, okay.
So primarily because of the parking?
Hmm?
Because of the parking changes?
Yeah, MIT no longer lets you park if you don't have an MIT parking sticker. At the same time, the city of Cambridge changed it on-street parking meters. So it's, instead of being free after 5, it's not free until after 8.
Oh. So that,
It's kind of like a perfect storm.
Though presumably we can at least hope MIT is a bit nicer about it once they've actually got their parking back. Since
Yeah, well, that's gonna be.
It's going to take a while before we get to that point.
yeah,
Yeah, because the algorithm I was using is if the parking lot was full, I wouldn't park, but I still put my name there on the dashboard. But I think that probably the MIT police just not gonna take the time to do it, they'll just give me a ticket.
Oh, right.
But my car requires as I said, requires a flatbed. They can't just put a hook on it.
Maybe they'll
It
get
is
one.
too hard to get one up in
Well, they would have to put it on the, you know, those little dollies that they have,
the, right,
and push it out and then bring it up onto. But they do that a lot. They certainly know how to do that.
Yeah. Although your car though is actually fun
Don't
because
say anything.
if
We wouldn't know.
if they, because I mean they could screw up and cause a puncture in one of the batteries and cause it to ignite, and I mean that would be.
If they were to do that,
Oops.
it would actually do me a favor. See, I have a 2013 Tesla,
Yes, that's.
and because my wife told me if I bought a new Tesla for $80,000, that she would divorce me.
Oh, jeez.
And although I had it as a loaner, I had it down there to get a new console and to get them upgraded to LTE from 3G. So if they, and I had a loaner, a Model X, and she loved the Model X. I mean, that Model X I had was nice, the gull doors, gull wing doors, but also instead of the protruding handles you have, the doors open automatically.
The thing I especially like about it is it's kind of like a station wagon. You can fold down the seats and have lots of cargo space.
Yeah. Yeah, it's the same frame. If you go into a Tesla dealer, they have a Model X and a Model S in there, and in the middle, they have just the frame with the front and the rear motors. Your four-wheel drive actually have two motors. One in the front axle and one in the rear axle.
I would almost expect it to be cheaper to simply stick a motor on each wheel, because that way you wouldn't need a differential. And
They don't have a differential. I don't know how they do it.
Yeah, I would.
Yeah,
well, I actually
they might.
I suppose it could be done if trying to think of the right part. If it was one set of coils with two stators.
Yeah, I don't know exactly the technology at that level. I just know that the motor is in line with the axle. There are no gears.
Whoa.
So if you switch gears while you're driving, it's just going to reverse the engines quickly. Whereas if you switch gears and, you know, a gasoline car while you're moving, it's not very good. I mean, go reverse the drive or something like that. You know, a lot of cars, the gear shifting is all done electronically.
I get a kick out of what is it, when they advertise for like cars that have built-in wireless and whatnot, and they're like, oh, built-in 4G LTE, like it's like you're using buzzwords. Like, it's like stop it.
I just upgraded
Well-
mine from 3G to LTE.
It's like
yeah, and I generally think of something like that, and I say, you know what? It's possible to. I mean, worst case, it should be able to communicate via Bluetooth. And you know what? It's probably better for it to connect to your phone, because that way you only have one thing that needs to be upgraded, not
Yep.
two, and one of them is generally very, 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 very expensive to upgrade.
The LTE or the internet connection
Right.
on the Tesla is required because they give you updates every once in a while. Every once in a while, I'll get a panel that says your car is going to get upgraded at 11 p.m. Is that right? You want to change the time or do it now or whatever?
Again, why doesn't it, can't it talk to, say, an existing cell phone and get connectivity that way?
It could, but what if the person doesn't have a cell phone? For instance.
Like, it's not like you can hook up your computer to the car.
Yeah.
Like,
Well,
or the
So
car
what
to
if,
your computer.
what if,
well, in theory, in
what
this
if my
situation,
what if my car is in the garage and I have my phone with me, I'm in the house,
Right.
and I'm too far for Bluetooth?
That. And plus, I'm not entirely. I mean, you can use. You can tether your phone to your car, or like the way one would tether their phone to their laptop. But it seems kind of convoluted. Instead of just having the internet connection built into the car.
Doesn't seem at all convoluted. It's just a case of, oh, it's talking to your phone, and your phone may be talking to either the cell network or maybe your home 802.11. It doesn't really
Yeah,
matter.
Yeah, but the thing is, phones are portable.
Yes, but the thing is that potentially it could download updates while you're driving and then install them once you finish driving.
And well, depending on your phone network, if you're on the phone, it doesn't. It might not. Because I know with Verizon, it's 2017, and you still can't be on the phone calling, and and navigation or something.
I'm on AT&T, and you can't do that.
Yeah, although if you're in the car, that may be a feature, not a bug.
But
I've had calls coming in a lot when I'm using my phone as GPS. I just won't touch the thing. I won't answer the phone in that case.
But one of the advantages, I think, of having in the car is what I mentioned, is the fact that you keep your phone with you. And the thing is, I can right now use my Tesla app, and I can connect to my car. BLU Livestream is active now.
So you guys hear about the WPA2 vulnerability?
Yep.
Which one? The most recent one that was, I think, a day or two ago?
Yeah.
So my location is 16 to 26 Amherst Street, Cambridge.
Hey, Bill.
Car. Bill.
Hello.
So to address that vulnerability, do I have to do anything other than just a DNF update?
Hello.
Pretty much, yeah. And then update and see if any of your wireless connected devices have an update. I'm probably going to end up contacting Verizon to see if they have kind of a patch for the
I can
modem.
just move this.
Yeah.
It's taking a strain to
Because they've got all sorts
a
of
little more time to respond.
HDMI.
Nice. I mean, this one works, so,
Yeah, as long as it works.
yeah.
We're thinking of having our install fests on Sundays to coincide with the MIT flea market.
Well, that makes a lot of sense. Nice.
We would basically be doing that twice a year at MIT, and then have two more of them out in at Dick Miller's place in where's that? Natick?
Yeah, Natick. Natick will be in February. I'll see Dick Miller shortly.
The next one here at MIT will be whenever the flea market is in May.
Yo, is it that when it picks up again? They don't do it in the winter, right?
Yeah,
Right.
Jerry tells me they don't have a schedule for it yet.
Yeah, they don't know what their parking situation is going to be because the parking lot next to their garage got turned into construction area for the power station. So all is in flux.
Yeah, Dre found a good room to hold it in, but we can't schedule it until we know what day it's going to be.
In front of
So
you.
the glasses I just knocked on it.
No.
It's too dark in there, I can't see which way the plug goes. So I'm gonna have to use a flashlight.
Yep, that's WPA supplicant.
I got to go to I got to go to the first DEF CON, the local DEF CON group here. Or not here, but over on Clarendon.
That's vaguely here.
Yeah, I mean, over yonder.
It's this side of Hartford. That counts as
Oh, right.
greater Boston,
Now
Cambridge.
you're knocking your mouse on the floor.
Yeah, I know. I get it.
And then next month.
I like to crawl away
next
sometimes.
month, you know,
I gotta train it better.
And we've got several.
Oh. Fedora 27 was released last week.
745 Atlantic Avenue.
Meanwhile, I can have the kernel portion fixed for my phone fairly quickly because I get to do that myself. I'm unsure whether that is required or merely one way to avoid part of the issue. I'm unsure whether it's actually one or a few different issues.
Do you have to update both the clients and the access points?
Yeah, pretty much.
Probably.
Well, for the new crack,
Yep.
Yeah, crack attack.
clients only.
Oh, really? I thought.
It's a client-side code vulnerability.
Right.
So unless you're using your router as a Wi-Fi to Wi-Fi bridge, it's client-side only. The problem there, of course, is that there are a lot of Internet of Shit clients that just aren't going to ever update.
Yep.
And there's a good chance your Windows 7 or Windows XP is not going to update.
Well, definitely Windows XP. Or definitely not Windows XP.
You know, so that there's, and you know, if your phone is 2 revs back, or 1 if your vendor's crap.
Yeah, my home router is running kernel 8.6.
Now that may have its own problems, but this isn't one of them.
No, that will have its own problems. You may be starting to get into the point where you're somewhat secure simply because no one's bothering with it.
Security by security, right?
Yeah.
Maybe. Wait, but does Windows XP even support WPA 2? Do we know this?
Okay, hold on.
Windows XP
Okay,
almost
Google.
certainly yes.
Does Windows XP support WPA2?
Yes, personally, I tend to prefer. I generally prefer actual wires because you know what? Those are a little bit harder to get signal out of.
And what are the latest updates for Windows XP?
Is anyone familiar with the Fedora, how the Fedora development project's been changing?
No.
I'm noticing something weird on the release schedule now.
Oh, they just stopped doing alphas.
Well, there's a line that says Fedora 27 final release, and the rain date was Oh, it's November, not October. Never mind.
Does that mean that they're admitting their betas are crap?
No, they just stopped doing alphas. Or they're starting with 27. They're starting just not doing alphas.
They're admitting that their betas were alpha quality?
Or are they hoping there are enough people that are running off live builds they don't have to do alphas? Those are two choices.
It's showing two different things with a final release date on it. One of them's called Fedora 27 final release, and the other one's called Fedora Modular Server 27 final release.
Modular, it's
So those are released separately?
I think so.
Okay.
Slightly separately. Like not too far apart.
But I was hearing reports that more or less the committees for Bluetooth and 802.11, it's more or less a whole bunch of different companies. They're trying to stick their own bits of technology in to A, screw their competitors, and B, be able to advertise that, hey, we've got this extra feature of dubious actual use.
Yeah.
And as a result, things like the security is absolute crap.
It's like how Samsung built their like exFAT driver into the Android kernel for their devices, and then somebody figured out a way to get the sort of liberate it from the main source tree, and now
I'll start you before.
now it's up on GitHub.
Whenever you're ready. Yeah, tell me when.
Although
I usually
annoyingly,
start to speak
the problem
about
is
15 minutes
that
after.
if you get that driver,
We'll see if
you
a few
stick
more
it
people
into
come
your
in.
kernel source,
If no one else comes in by
and
quarter after.
that's it. You don't have a way to turn it on or off.
John Malloy
If you
usually
so
comes in
desire
5
to
minutes
get
before
rid of
school
it
leaves.
and say maybe use something same
When
like
we show up, we're not
UDF
serving
instead.
food.
What?
When we show up, we're not serving pizza.
Well, no. I was gonna tell a UDP joke, but I wasn't sure if anybody was gonna get it.
What's UDP, Joe?
Just hold it.
He
with a
just
single
told it.
packet.
Yep, that one's in several Fortune files.
Yep.
Trevor, are you still you're using Fedora mostly on that?
Well, my primary laptop is Fedora. I have another laptop I run Ubuntu on.
I switched to Arch.
Oh, yeah?
I am no longer a Gen 2 dev officially. I am resigned.
That
So what do you like about Arch? It's better than Fedora or Ubuntu?
I find that I like the package manager. It just makes sense to me. I've never got that personally, and I think it was mostly just the format of the output of the log lines or the commands and how you search for things. I find that coming from Gen 2, where everything is in emerge and then something,
Oh, yeah.
just having that versus apt. I mean, I'm sure you could replicate it with apt, but
Yeah, I tried Gen 2 a long time ago. I think I ran it for almost a year. Then there was an update that rearranged
that's-
everything, and when I did the update, it just broke the system completely.
that sounds about right. That
Yeah,
seems to have happened.
that especially happened around, what was it, going from GCC 4.9 to
That's right.
to 5.4, and then 5.4 to 6. Whatever, and when 6. Whatever hit, they had a new ABI change, and so you had to recompile everything. God help you if you were running GNOME and you had to recompile WebKit, which is like stuck on a single build thread because of a base
I gave up on Gen 2 when the compiler shuffle broke X Windows.
Well, that's one of
Figured if I had
that's
to-
one of the things, right? Is you get the latest, and I, as you know, I was
Latest
a
and-
developer for
I know.
like
most
12
broken.
years.
That's
then
how
10
I got
years.
infected.
And I still run it on one of my boxes that I want.
think it bit
But honestly,
me.
I switched to Arch, and it was because I wanted the latest versions, and I found that I was looking for a distro that would get me the latest versions of things, but
Mhm.
would not break every time I did an update.
Yeah, the thing about me had nothing to do with the packages.
Yeah.
So,
that
so the
sounds-
break
they-
is where
they-
you
Right.
run-
Sorry.
In
not
this
break
case, they
is where you
completely,
run with SID?
no, they completely, in this case, they completely reorganized the file system. So when I did the upgrade, the whole machine was trashed.
Yeah,
Oh,
nice.
that might
At
have
that point, I
been
just
That
dumped
was-
that Gen 2 and never looked back.
Was that when they symlinked user bin to slash bin or something?
Yeah, there was the big.
No, it was a lot
there
more
was
complicated
the big
than that.
user move.
This was like maybe 10 or 15 years ago.
Yeah, that may
Wow.
have been the user move actually.
Meanwhile, I think
No, this thing happened to me long before Fedora did that thing where they got rid of user.
Debian, I think the overall quality seems to have decreased over the past 5 to 7 years, though it's still pretty decent. And of course, then there's the issue of systemd breaking everything.
Systemd only was default within the last release, or sorry, the release prior to that.
The current release.
No, I mean like Jesse and Buster or whatever.
Yes. Meanwhile, there is Devuan, which has the specific. It seems to mostly be working. Unfortunately, it's still heavily reliant on Debian that it exists.
I mean, if you're so dead set against systemd, just run Gen 2. Just open RC by default.
Meanwhile, I think the other thing.
The question is, which is harder to live with, systemd or Gen 2?
Well, if that's your thing, then you could always do systemd on Gen 2.
Well, no,
Which
it
is what
isn't.
I used to do. Which is what I used to do when I ran Gen 2.
Okay, well, we've got that sort of insanity. I think to a point, really, one of the major things that would be a step forward for a number of Linux distributions would be to start going into the various projects and encourage them to, you know what, instead of having the compiler link you to this library, DL open it instead, because that way that library becomes an optional dependency rather than something that you have to have. Thus you can conditionally link on almost all of your libraries that are really optional. That way you can avoid installing.
Containers tend to solve that type of problem.
I mean, or during
Because if there are libraries that your program wants to use, but they're not guaranteed to be on the system or the same release as the system.
No, that's not what I'm talking about. That's unrelated. The point is that quite a few programs, they have got libraries that are really kind of optional. I mean, the number of things that can potentially use MySQL or PostgreSQL is pretty impressive. But the thing is that around 80 or 90% of those don't really have that as a requirement. It's a case of, oh, this gives you extra features, and if you're not using those extra features, being able to completely remove those is actually kind of nice. And the problem is that by doing GCC-L MySQL or -L Postgres, the problem is that it means that the binary will break if the library is absent. Whereas if you use DL open, you can simply say, oh, the library is not there. Well, okay, that functionality is disabled, but everything else still works.
or just
Yeah, I would agree with that. I missed the point, but yeah.
I was gonna say, or just do what is it? /configure --
The problem is that means you have to rebuild it from scratch, whereas if you DL open it, you can check for whether the library is present, and if the library is absent, you simply say, well, that functionality is disabled,
Yeah,
but everything else works.
Yeah, I mean,
That
they
was the
should-
reason I moved to Gentoo so many years ago, right? It's because you set up those flags. I'm
Yeah,
building
well,
a
the
box
thing
with
is,
Postgres and not MySQL, and then it just builds
The
everything.
thing is, if you DL open it, you don't need to rebuild them. And anyway, and I would point out that it's actually after 8 at this point.
Yeah,
Should we
it's
start?
8:15, I usually start quarter after. We'd start now.
Yeah.
Does everybody know Rajiv?
So hello, recognize many faces here. My name is Rajiv Miglani, and I will talk about SSL and TLS as my latest thing. As you know, I've done a number of presentations here at BLU on Gentoo Linux. I'm not sure if I gave my Ruby on Rails presentation here.
Yes.
But I do that at MIT during IAP as well. Every few years, change the little talk that I'm giving. So I am currently at Akamai Technologies. We are a CDN, a contract distribution network, offload network, one of the largest, if not the largest, CDN on the internet. It was founded by MIT professor and a number of grad students based here right in Kendall Square, and handle some of the largest sites on the internet, and something, depending on how you measure it, between 30 and 50% of internet traffic is actually served by Akamai servers. Tonight I am representing myself. I'm not speaking as an Akamai employee, but I will tell you that much of what we're going to be talking about are topics that I deal with on a day-to-day basis at Akamai. I'm the product manager for Akamai's secure CDN, the secure network, which we hope in the next few years will be the only network, and that all the traffic will move over from HTTP over to HTTPS, and we'll take over all of that. So my role there is really determining what are the features that the secure network should support. How do we keep the network up to date with the appropriate TLS versions, ciphers, certificate provisioning, and all of those things that a customer might need specifically to establish to make sure that we can establish an appropriate TLS handshake between their end customers and the Akamai servers. And if anyone's interested to learn more about Akamai, happy to talk about it after. So I want to talk about SSL and TLS. I hope everyone here knows that the S in HTTPS stands for TLS, not SSL. But that's always the joke in the industry. SSL is the older technology, and now TLS is the new version. There is a great book out by Ivan Ristic called Bulletproof SSL and TLS. If someone wants to learn more about how to set up a TLS server, whether that's Nginx or Apache or Exim or Dovecot or any other custom client even on the client or the server side, and you want to know what's going on, this is the go-to book that I recommend. It covers the full range of things that you need to know about the TLS world, what's going on, and how to set up clients and servers. And the great thing about it is whether you buy it online or in print, Ivan is constantly updating it, and several times a year you can go download the new PDF, which covers all of the latest topics in the TLS world. And this is actually something really important to know. If you are running a TLS client or server, it's unfortunately not something you can just set up and install and then forget about. You do need to pay attention to what's going on in the industry and what exploits are out there, what vulnerabilities are out there, and keep both up to date. Now, most people don't have to update their TLS libraries. You will update on Linux either GNU TLS or OpenSSL or LibreSSL, depending on your distro. I think there's another one. Boring SSL is out there.
There's NSS too, Network Security Services.
That's unrelated. Well,
That's gonna use one of the libraries under the hood there. And so normally your distro will keep that up to date. Accept those updates. Don't wait. There's reasons that they push them out, and they backport fixes to address all sorts of vulnerabilities. But the important thing to know if you're running a TLS server is that updating your libraries is usually not enough to stay current with what's going on in the TLS world. That is to say, if you're running Apache and you set up your server, you will likely have to copy a config from somewhere to set what kind of ciphers your TLS server will accept when it does the handshake with the clients. That list of ciphers needs to change over time because ciphers become vulnerable just through the natural progression of increase in computing power, and then also through vulnerabilities that are found. As a side note, there is a new module coming in Apache. I believe it's in development right now, where you can set your sort of a profile to say you want a modern TLS profile or an intermediate TLS profile, perhaps to support older clients, or an ancient TLS profile to support Windows XP, and then you just set that, and then as Apache will determine what that means, and then as they update the Apache versions, you'll get new definitions of those.
If I attack Apache successfully and can get the null cipher added to the secure option, I expose everybody.
That's right. But then you probably, as a server admin, have bigger problems.
what do they call the config to support Windows 3.1?
I don't. Did Windows 3.1 ever support SSL? I don't believe so.
Don't know.
I don't believe so. I think XP was the first one, and in fact, not XP out of the box, but a XP later version was updated to support SSL. And so, and surprisingly enough, there are still XP clients out there, and at Akamai I see them. I have customers who see them, who still use them, and who still want us to continue supporting them. So they're still out there to get that. But the line that you need to say as a server admin, or even just a user, is get your TLS versions to the latest and get the configs to a secure config. And we'll talk about how to check those. So the first topic I want to talk about is this movement called TLS everywhere in the industry. And I don't have any specific slides on this one, but this is the movement of really all HTTP traffic moving to HTTPS traffic. We see this happening in a number of ways. If a server or client wants to support HTTP2, then TLS is required. Technically, you can implement HTTP2 over non-TLS connections, but none of the browsers have implemented it that way. So if you want the best performance, you want to take advantage of the latest specification and the latest features of HTTP in the version 2 of the protocol, then your client and your server need to support TLS. And so this is pushing a lot of customers to say, okay, we need to go and update our servers and get to TLS. The second big push driving everyone to implement TLS is Google. And those of us in the industry that follow this industry really like their push. Try again, I'm speaking as myself, not as Akamai here. We like that push because we effectively, as we've seen through the most recent WPA2 crack, have had this philosophy in the industry to not trust the network. That you have to operate in a way that says that the network is untrusted. And so don't depend on a firewall, don't depend on IP access control lists, don't depend on WPA2 or other Wi-Fi security to protect your data in transit, but instead encrypt the data, encrypt the connection from one endpoint all the way to the other endpoint using a authenticated, encrypted protocol. TLS with the right ciphers gets you those. Google is pushing for TLS because they know that there's a lot of HTTP injection and interception going on. If you have Comcast at home, for example, the only high-speed internet that's available in my home, I don't have a choice. Comcast will inject JavaScript into HTTP traffic. So you might be surfing to a website, have your browser connected to a server that is not on the Comcast network, and Comcast will inject a piece of JavaScript into the web pages that come back to your client, telling you, for example, you are close to your data cap for the month. Or
They have a data cap?
in some areas they do. In some packages they do.
Holy cow.
Most of the time, they don't enforce it, but if you're an egregious user and you go way over it, they will start doing that. So this is bad for a number of reasons, right? As a site operator, as a server admin, you should care about this because you've spent all this time and energy and effort to build your infrastructure, to deliver your application's content to your users, and your users are not getting what you want them to get. They're getting what Comcast wants them to get, which is your content plus the Comcast JavaScript. So Comcast is hardly the only vendor that's doing this injection. But it's something to note that we've seen issues and we've heard of issues where customers will call up their, will be using a site, they'll call up the site and say, hey, this site's not working, and it's because there's injected JavaScript which happened to use the same variable namespace or something as JavaScript on the page, and then they conflict. It's a terrible experience. Not to mention the dilution of the brand of your, again, as a site operator wanting to present something to your users, you may want to control what those users see on your own web page and not have them various pop-ups. Another thing that we see happening is that ISPs are increasingly sniffing the traffic that's going across their network and selling that data. Hopefully in aggregated form, hopefully not in identifiable form, but we see this happening all the time. They may, it's one thing to use that data for their own network shaping and traffic shaping and peering and looking at that type of thing, but we see increasingly that these ISPs are taking and sniffing the traffic that's going across their network and selling it for the purposes of advertising or analytics or other usage. Again, as a user, I don't want that data sold. I don't want my data thrown into this big pot of stuff. And so I insist on TLS everywhere. And for those sites that are not yet on TLS that I care about, I'll actually put something on Twitter or email them and say what's going on. So we see that one last piece that's pushing the TLS everywhere is that browsers are starting to mark sites as not secure. So Google will do this, and we can take a look at one. Let me just bring up, make sure.
I think they're doing it with FTP sites now, or in the next version, they're marking FTP sites.
That is correct. They're doing it on a number of on FTP and a number of other protocols, and I'm bringing up CNN here as an example. So you'll notice I just loaded it in Chrome. I'm running version 62 at a time when 62 I believe is still in beta. I run the beta version, and it will say, okay, it's not secure. Your connection to the site is not secure. And most users are not clicking on this little icon to look at this, and that's totally fine for most users. They're gonna look at this, but as soon as you bring up the search box and you start typing in here, and you say, let's just search for something, and you'll see that Chrome now identifies this site as affirmatively not secure, is what it's called. So again, this is in version 62 which is rolling out in production this week. And so if you are a site operator and you have any type of form field on your site, and your site is not secure, then when a user goes to that form field and starts typing in it, Chrome is going to start marking it as such. And this is something we expect, again, to get a lot of users concerned. Why is this not secure? Well, it's not secure because there's no TLS.
It's not bright flashing red yet.
That's right. Right. It's not the red icon, but
That's
slowly
next
they've been moving for it. In the last version, for example, it was just on pages that had form fields marked as password fields or credit card fields. And in this version, they're doing it on any form fields on the page. And then we're going to see Chrome moving even further in that direction of just doing it for all HTTP sites. They haven't said when yet. There's a lot of experimentation and a lot of talk in the industry of when is the right time to do that. But it's going to happen. My guess is it will happen sometime in 2018 or early 2019. And so you really need to, again, if you're setting up a site today and you're installing any kind of web server or load balancer, just like you might set up the right domain for your site, you want the www, or you want the top level domain to redirect to the www, and you put a redirect in, just like that, you need to start setting up a TLS cert, an SSL or TLS cert for every site you put up today. And we'll talk about Let's Encrypt in a few minutes, about an easy and free way to do that nowadays. But it's now a requirement to any site that you create. So when you do set up a site, how do you check that it's secure? How do you know you're getting a good configuration? So I'm going to talk about Qualys and their SSL Labs test and actually run through it. But I do want to talk about how you might start of setting this up. And when you're creating your site, you need to actually configure it in some ways. And the first place that I usually go is the Mozilla Wiki has a great page, and I will share all these links after the meeting, so you don't have to write them down. But the Mozilla Wiki has this great server-side TLS page, which talks about how do you configure your web servers to actually have a modern TLS setup and what to do. And so the first way they walk you through it is by starting with what configuration you want. What's your target clients that you want to support? Which versions of browsers? I would, if you notice these versions that are here on the modern client. I mean, Chrome 30 is out for years, right? So, Safari 9 is already 3 versions back, and so. Today, I would recommend really trying to start from a modern profile and implementing that. If you know you have older clients, i.e., 8 on XP or Android 2.3, then perhaps intermediate. You start with that type of configuration, and then just scroll down, and it'll tell you these are the various cipher suites, TLS versions, TLS curves, the certificate types, the algorithms, all of the parameters you might need. Now, most of these, you don't have to become a TLS expert to do this correctly. I'm going to show you an easier way. But these are the types of things that, as a TLS server operator, you have to be aware of. Most of your clients will take care of this automatically. But you do need to be aware of what is actually, what some of these settings are. And what some of these ciphers are. And I'm happy to go through them if anyone has questions. But again, I think these recommendations from the Mozilla Foundation are excellent. They keep them updated and are really a great guidelines. So one of the other things you can do is you can look at, they do provide that in the JSON version if you have a something you want to script in some ways, which is great, and then some recommendations for ciphers and cipher suites that should not be used. DES, triple DES, RC4, SSL v2. You'd be surprised at the number of large companies that have hardware, for example, that cannot be updated, right? It's one thing to update your laptops or your desktops or your servers, and okay, you have an operational plan and you phase them out every few years. You'll be surprised at the number of companies out there who have hardware devices. It's notorious in the broadcast television world, for example, where they will have physical devices which are streaming media, and they want to do live streams, and this box that they bought 10 years ago, which costs them hundreds of thousands of dollars and are deployed all over, are just not able to be updated because the vendor just doesn't want to do it, and those still need SSL v3 support, for example, if it even is secure at all, or various other older ciphers. And so those are out there, need to be supported.
Something like that, you would almost expect the vendor to say, okay, here, spend $100 and we'll get this Raspberry Pi that handles all the same functions. Oh, and also uses less power to do all that.
Yes. Yes, you can. But many of the, right, and we always try and, I always try and push, customers, why are you asking for SSL v3? What is the reason, and we'll work with them too.
That can actually backfire in some situations. At my last job, I deployed a number of open source technologies, including OpenVPN, and the company did this reorganization where they decided to consolidate all the IT under the main corporate headquarters in Germany. And he just decided anything that didn't cost any money was automatically insecure, no matter what. And just everything, he ripped out everything and replaced it. Spent like $100,000 replacing stuff that was less secure.
Seen that as well. So we can talk some more about some of the other various pieces that they recommend. In fact, I'll get to many of these things. But I'm scrolling down to this recommended server configuration example. And we can look at it. This is actually an image, but I'll bring it up in another window and we can look at it. This is the configuration generator, which is really, really handy because you pick your web server, you pick the type of clients you want to connect. If you need to specify the versions, you specify that, and bam, you just copy and paste this config, and you've gotten all of the Mozilla recommendations for how your server should be configured. Very, very handy. And again, in a newer version of Apache that's in development, some of this will be automated. I don't know about the other servers, but this section, for example, will be automated with that new module that's coming. So keeping up with server configuration is really important. Once you have your server configured well, let's go back to Qualys. We'll talk about how do you verify this.
Could we go back to that previous page? I just want to look,
Sure.
Get what the URL was. wiki.mozilla.org/security/.
So I will actually recommend a different URL to you to start with. I didn't have it specifically for BLU tonight, but again, I've given this class before. If you go to sipb.mit.edu/IAP/SSL-TLS, all of the links that I'm sharing are actually on this page, and you can just get them right from here. So, or if you search for current issues in SSL and TLS, you'll wind up on this page. Please get the links from there. So I've set up a server that I run my own server on, and I will just bring up the SSL Labs test right now. This Qualys is a company, a for-profit company, but they run this great service for all of everyone's benefit called SSL Labs. that really keeps track of the SSL industry and what's going on. One of the great features I love on this site is the link to all the documentation, and somewhere on here is a link to the history. I have it bookmarked, so I don't think they've updated their page with it, but we can look for that. But they have a history of SSL and TLS that talks about all of the major incidents that happened. There's some great help on configuration and how to actually do best practices. And the one that I want to highlight here are the client and the server test. So let's start with the client test. You just come to this site, you click on test your browser, and it does a few different types of TLS connections, and then tests the various capabilities of your browser. So I'm running, again, the latest version of Chrome, actually the beta version of Chrome. It will tell me that I'm not vulnerable to all of these different vulnerabilities, show which cipher suites, which protocols that my browser supports. It's a good way of making sure that you are running with the latest browser, and bring up SSL Labs on Safari on this Mac and just show you an example of how it's a little bit different. The cipher suites are quite different, right? So Safari does not support, on Safari 11 here, does not support triple DES, for example. Chrome still continues to support triple DES, necessary in some environments, but Apple is being a little more aggressive and not supporting those. You'll also notice the cipher suite ordering is different, especially with what are called the forward secrecy ciphers, the ECDHE, the ephemeral Diffie-Hellman ciphers. The ordering is different. Again, it's a preference for how these browsers implemented. There's implications on each one of these. Again, happy to go into some detail if you're interested in those. But testing your client on this is always very interesting to see, especially if you're running a mobile browser. You might be surprised at what that browser actually supports. Let's look at the server test now. Actually, let's look at the other user agents. Again, this is a very handy chart for showing the different versions of clients, the major features that they support. You'll notice that when you look at forward secrecy, an important safety mechanism in the ciphers, that there are some browsers, older browsers, that don't support them, again, back in the XP type of days. But all modern browsers supported it, so that's why it's recommended. And if we pick a particular browser to look at, I'll just pick an older version of Safari that some users are still stuck on. For example, Safari 6. This is a good reason, again, to keep your browsers up to date, keep your TLS clients up to date. Sometimes that might mean updating your entire OS. In some cases, I've had to push people to say, you need to no longer use that iPhone 5 because it's stuck on the old iOS version that does not support the newer ciphers, the newer TLS protocols, and you need to physically change your hardware out because the vendor no longer will provide updates for it.
Apple loves you for that.
Yes. But it's not, and I pick on Apple to a certain extent because you know, it's not easily to run newer versions of iOS on their older hardware.
Yep.
But this applies to all types of clients. I have spoken with a major car manufacturer, not luckily the one Jerry's car is made by, but other car manufacturers who are embedding TLS clients in there. and we'll come back to Jerry's card in a moment, but if you talk, I've talked to these customers. They are great car manufacturers. You know, their cars are solid and stable and meet all of the transportation, National Highway Transportation standards, crash test standards. But their TLS clients are garbage because they still are functioning under this model of, we built a car, it's a 2017 model year XYZ car, and we ship it. And that's great. And if there's a safety issue, we'll do a recall. They have not built in any capability for updating the software stack in said cars. And we had an issue, we've heard of an issue where a customer shipped a car, 2015 model year, and did not think to be able to update the trust store of the cars. So they only embedded a single root certificate in that car, so that when they get their certs, and maybe we'll talk a little bit about how certs get validated, but a cert gets validated up to a root certificate, and you have a trust store in your client that says these are the root certificates that it will trust, and any certificate it encounters on the network has to actually chain up to that root certificate. So every TLS client has a trust store. Most desktop and mobile clients have several, maybe 100 or so roots in there. This car had one. And that root certificate was then no longer supported by the certificate authority. So it is no longer, and there's no way to update the trust store. So it is no longer possible for that TLS client to actually make TLS connections, because it verifies the dates of validity, but it does not have a way to update the trust store. And so there's no way to actually get a new certificate that is valid today that chains to that older root. And it's a challenge. It's definitely a challenge. When you're implementing TLS clients, you need to pay attention to these. And again, I refer you to Ivan's book, which covers this in a lot of depth.
Yeah, so I'm trying to do this, and it says, if I just go to SSL Labs, it says there's a firewall restriction and it can't test any of the protocols. That, like, I'm just running ordinary Linux Mint without anything crazy.
That may be, you may have a built-in firewall that's built into Mint, or that may be MIT new lockdown IT fascism preventing packets going in and out. One or the other.
It's not MIT.
And I'll tell you that my laptop is on the MIT secure network,
I'm on MIT guest, so.
the affiliate network, not the guest network. So that makes part of it. But yeah.
There's three choices for MIT, either both guest and plain non-secure MIT are reasonable options. But Mint might be shipping a default on firewall now. I would hope so.
But it blocks, it says everything, all the protocols are blocked by the firewall.
That's really interesting.
Good.
On the other hand, apparently you can get on one that's marked MIT without entering any authentication for yourself, which is kind of nice.
I prefer just using an Ethernet cable.
That works too. So let's go back and look at their server test, because that's great if you're setting up a site. So you can come in here and you can click test your server. You can look at some of the recent tests that others have run. I'm going to run it on my own site. I would ask that if you are testing it, you don't run it on my site while I'm running it. But it sits here for a little bit, and it chugs away. It takes about 1.5 to 2 minutes per IP address for each site. And what it's doing is it's simulating handshakes for every SSL and TLS version, for every cipher, different orders of those ciphers. It's testing for various vulnerabilities, insecurely generated RSA keys or ECC keys, OCSP stapling, HSTS header, all sorts of things that are, and we'll look at the report in depth. And then at the end of that test, you get a grade, which summarizes how well you've configured the site. I shoot for an A. That is not always possible. Some customers and some users and some sites have reasons that you can't get an A or even an A+. But again, I would recommend going to try and get an A with your configurations. I'll also tell you what I tend to do with vendors that I trust or need to trust. For example, my credit card vendor. I'm logging in sometimes, looking at my statement. I come here and I test their site, their online site. See, it's not to if you get a C on this, it doesn't mean the site is hackable necessarily, but it's a good indicator to say, does the team managing that site care about what they're doing and know what they're doing and are knowledgeable? And I found out that my credit card company was not. They were consistently getting C's on their online banking site, and I switched to a vendor, to a bank that gets an A, and that's again knowing what I know about this, that was important to me. So I don't expect most users will do that, but again, as you saw, it's not too hard to get an A. If you go to the Mozilla site, you select the modern configuration, you put it in here, you're going to get an A without changing your application at all, just changing your server configuration. So let's look at this report. You'll see it talks about 4 different areas of the TLS connection: the certificate, protocol support, key exchange, and the cipher strength. And gives you some detail on the certificate, on how it is, who's the issuer, whether it's revoked or not, the various certificate paths, again, the TLS versions that the server is set up to support, the ciphers that it's set up to support, and it actually will simulate various handshakes with all the different known popular TLS clients out there, which is very useful for building a site. You want to know, are these going to be able to connect, and we'll show you which ones could not connect, and just know, okay, well, I'm going to effectively be limiting some of the traffic that might come to a site that I'm setting up. We'll also talk to you about the various details of the TLS protocol and how that's done. I won't go through all of these, but just know that there's a lot of information here, a lot of tests in here, and you want to see green or black all the way down the board. If you see orange or red, then it's not a good state to be in. I'll keep this up for reference for a moment. Let's look at some of the other ones that have gone through that are pretty bad. How about Fox News? That got a C, and we'll look at that. Why did they get a C? So the server uses RC4 with modern protocols. RC4 is a really old cipher, and not something that really should be used today. And this is unfortunate because they could very easily add additional ciphers to the TLS configuration that use just about the same CPU as RC4 does or AES does. So without increasing CPU usage on the server, and support better protocols, better compliance. There are reasons to use RC4, but again, public internet is not a place I would want to see them. For example, if you are a corporate site and you want to intercept TLS traffic to monitor what your employees are doing, you can do that through various ways. One is by installing your own root, but another way is by just using, by installing a TLS middle box, which does this interception, and those sometimes only support certain ciphers, right? So if you know that you want to be able to support these older TLS interception boxes that are out there, you may need to continue to support these older ciphers. Although I will say, there's no excuse for not supporting the modern ciphers as well as the older ciphers simultaneously, because the clients and the servers will negotiate. So this is a pretty poor configuration. The fact that it only supports it prefers RC4 over AES, which is just ridiculous, because most clients will default to the server preferred order, and that even clients that support AES won't use it when connecting to the site because RC4 is presented first. So at the very least, this is an error in configuration, and those two should be swapped in the config.
Well, maybe it's a case of they're trying to save processor power.
That is possible, but it's very hard to find a processor made in, let's say, the last 5 years or so that does not have hardware accelerated AES.
Yes.
Including, all of our laptops, not necessarily the mobile devices in our hand, but I cannot imagine that the physical server that this site is running on does not have a hardware accelerated.
You never know.
AES in it.
Well, some of us run older laptops.
Yep.
And for those, there's a great cipher called Cha-Cha Poly, which is optimized for non-AES, optimized for software. In fact, most mobile devices will use Cha-Cha Poly to connect. I'll give you an example. On my site, I don't believe that I list it first, and so on my site I'll list Cha-Cha Poly second. I don't have it configured in the way that it takes advantage for mobile. Again, it's just my personal domain. But many sites will advertise Cha-Cha Poly as a cipher, not first, but later on. And if a client connecting, when a client and server do the TLS negotiation, the client will send the list of ciphers it supports, and the server will send the list to negotiate. If the client says it does not, or it lists Cha-Cha Poly first, because let's say it's a mobile device, so Android, iOS will list Cha-Cha Poly first, then the server will be configured in a way to say, okay, don't present the AES ciphers, present just Cha-Cha Poly. Because Cha-Cha Poly is actually faster on non-AES accelerated hardware. So there's ways around this, again, when you look at Qualys, they have a lot of this detailed on the browsers. We can take a look, for example, at let's pick Android 6. You'll see that it has they do it with the old, so there's slightly different cipher names, but for the most part it's the same thing. They'll list Cha-Cha Poly first over some of the other ciphers. And again, that's because Cha-Cha Poly is optimized to run in software on mobile devices that don't have the AES acceleration. So there's a lot of things to think about when you're setting up a TLS server, and you really want to not have to think about them. So use some of the default stock configs out there, and then test your site with the Qualys test. Don't get a C, don't get an F. Like that's not necessary nowadays. It's easy enough. We can still support lots of different clients, even older ones, and with a good configuration for those that support the newer protocols. There's a great server that does a lot of this for you. It's called the Caddy Server, it sets all of this up for you automatically. It was designed with HTTPS in mind, unlike every other server that's popular, Nginx, Apache, for example, all of these are add-on modules. Caddy is built in with it. Again, that's not such a big deal nowadays. You install Apache, you install Nginx, Lighty, you're going to get TLS support built in. The nice thing about Caddy is you actually set it up, just install it, literally in this way. You make a Caddy file, you put the host, you set up what you want it to do, maybe point as the fast CGI backend, and you run it, and that's it. It will go out, set up TLS, talk to Let's Encrypt, get a cert, install the cert, and do everything for you. Literally, these are the steps to get an HTTPS site up and running. You just create this file and then start it, and you're up and running.
It talks to Let's Encrypt for you?
Yeah.
Okay!
Yeah. It will automatically do all of the certificate requests and setting up. And then as long as you keep it running, it will automatically renew your certificates before they expire. So, it's, again, very little reason not to do TLS today. I personally don't run Caddy on my servers. The only reason being is that it's not in the default package manager in Arch Linux, which is what I run. And so, as soon as it gets in the main line, stable package line on Arch, where I don't have to do manually installing the packages, I would personally switch to it because it's just this easy and it just works, and it's great. So you're setting up a personal site, something small, VM type thing. Check it out. CaddyServer.com. Really easy to use.
So it would basically replace Apache.
Yeah, that's right. You can put it in front of Apache if you want to. People know to do that. We'll talk about Let's Encrypt in a little bit and how the certs work. But keeping on the TLS Everywhere theme, I want to take a brief tour into sort of how the TLS world, browser and server, work and agree on things outside of the scope of TLS, which is an interesting thing, right? So TLS is an IETF ratified protocol. It runs on top of TCP. I'm sure you can run it on top of other things. There's other protocols for doing encrypted web communication like QUIC that's in testing. But there's more to it than that. There's sort of more to just TLS, right? And there's certificates. We talked a little bit about this. You need a certificate. You need a certificate on a site, and that certificate you present on that site needs to chain up, needs to be signed by a certificate authority, and that certificate authority's root certificate needs to be in the trust store of all the TLS clients you want to be able to connect to that site. So again, most of us don't think about this. You just fire up your browser, and you go to a site, and it seems to work. But there's two very important groups involved in that process: the browsers and the certificate authorities. So the big browsers are all part of this group called the CA Browser Forum. It's a consortium of browsers and server vendors that have gone together, an industry group, to address some of these questions of how should things actually work in this certificate world. And so they have a set of documents, or a document called the baseline requirements. And you can go and look at these baseline requirements, although I would not encourage it unless you really want to get into it. But the baseline requirements documents are effectively a set of agreements between the browsers and the server vendors that details how TLS certificates should be issued. What are the rules governing their issuance, right? And the browsers say if a certificate is issued following these rules, they will trust it, and the certificate authorities say we pledge to follow the rules in our certificate issuance, and then that's how we sort of get this agreement between the two parties. A lot goes on in the CA Browser Forum. It is again, it's an industry group, but there's a lot in here of how certificates are actually validated and issued, and what the requirements are, and Again, it doesn't talk about the TLS level. It doesn't talk about the X509 data structure, for example. But it talks about if a customer is asking for a domain-validated certificate, what are the requirements? How should a certificate authority actually validate that the requester has control over that domain and is allowed to get a certificate for that domain? What are the steps for doing that? And then how should that certificate then actually be issued to that requester? It's the same for organization validated certificates, OV, and EV, and then for extended validation certificates, EV. But there's a lot in here that goes on between the browsers and the CAs on changing of requirements. Sometimes this group does not work as fast as the browser vendors or as may want, and sometimes they don't work in ways that the certificate authorities want. But it's good to have a group of where this stuff, where the issues are discussed, and you could take a look at it of what they're talking about. One of the most recent things that came up is called CAA, and so this was done by browsers and CAs together, and CAA is an actual set of DNS entries that you add to your DNS zone that says which certificate authorities are allowed to issue certificates for this domain that you have. So here is the domain example.com. If you put in its DNS zone this CAA record, this particular one that's here that says let'sencrypt.org, then only Let's Encrypt would be authorized to issue certificates for this domain. It doesn't mean that they will, right? You still have to do all the validation. But it means that, for example, if you go off to another certificate vendor, a certificate authority, and you say, I want a certificate for example.com, that certificate authority will check this record in the domain and will say, no, we're not authorized to issue. And they will not actually go forward with that certificate issuance.
So if you installed that, you would be prevented from getting any value from paying for a certificate.
In this particular example, yes. That's right.
What's the...
You can put multiple...
What is the latency to retract that?
So it's DNS. So it's whatever the TTL is of the DNS that you put in. And if no one's if that other CA has not gone to check your domain, then it's presumably as fast as your DNS server is updated.
Hopefully your browser also checks this, because an unscrupulous certificate authority would happily issue it, and or a government putting pressure on a certificate authority would happily issue such a cert, at which point the browser needs to double check and say, hey, wait a minute, this isn't kosher, something's happening.
That is a great point. Let's talk about that for a minute. So browsers do not check this record, and there's a few reasons why. The first is this governs the issuance of the certificate, not the use of it. So I could, for example, set up my CAA record to be, just pick an example, Symantec, big issuer of certificates. I can go off and get an EV certificate from Symantec. They will check the record. They will say Symantec.com, perform all the validation, get my EV cert. It's valid for 2 years. I can then change the record to say no one can issue. That certificate is still valid because I've gone through the validation steps. The CA has issued that certificate. It has a not before date of today and a not after date of 2 years, today plus 2 years, and that certificate is still usable.
So this tells other CAs not to issue certificates to somebody who's pretending be your U-Corp.
That's right.
But it doesn't tell a browser that their corporate IT department has shoved a locally created self-signed CA certificate into their browser.
That's right.
When they redeployed the operating system, and therefore they're making up Google certs and Pornhub certs and whatever other certs you ask for.
That's right.
On the fly.
I know you used Google as an example. Google has other, well, I should say Google applications have other special protections in them. But yes.
Chrome will defend against that.
That's right.
Through pinning. Google.com addresses and other Google properties, but Firefox doesn't.
Let's tackle the second part of what you said of how the certificate, how a browser checks that the cert is still okay, that it's still valid, right? So that's handled primarily through revocation, and we will talk about OCSP as the primary means of checking revocation today in a little bit. But again, CAA is all about issuance. You can have multiple certificate authorities in the CAA record. There's also a way to report CAA violations. You can ask, you put in these lines in this example here, and the certificate authorities will send a notification to you if there's a violation. What's interesting about CAA, getting back to the CAA browser form and how this works, is this is primarily on the certificate authority side, right? There's no browser involved here, and all the certificate authorities now, per baseline requirements, are required to check CAA records when they before they issue certificates. That was a new requirement as of the beginning of September. But you were asking what's to stop, or we were talking about what's to stop an unscrupulous certificate authority from actually going off and issuing a cert and ignoring the CAA record, right? And definitely that there are misissuances, instances of misissuance that happen all the time. What's to stop them from doing this? So what's to stop them from doing this is, again, back to the trust store, right? Your TLS clients ship with a trust store. You know, on Linux, it's like CA-certificates. It's a file that literally lists the acceptable root certificates. Chrome on most platforms defaults to what the browser, what the operating system has selected as the trust store, and so you can actually on various operating systems, you can look at this. I'll bring it up here. Here is the trust store on Mac OS 10. Use the Keychain app. You can look at it, and these are all the root certificates that ship by default on Mac OS 10 of what's actually trusted. And so the agreement here.
Scary ones in there.
Sorry?
And there's some scary ones in there.
There are some scary ones in here. We'll talk about that. We can talk about that. But there is an agreement between the browsers and the certificate authorities, and most vendors will only ship with a list of root certs that are from certificate authorities that have agreed to follow the baseline requirements, right? So what's to stop some other CA from issuing certs? Nothing. I could go on my laptop right now and use OpenSSL and generate a cert for Google.com if I wanted to. And I could put it up on my server on a public IP address on the internet. But if I somehow manage to co-opt your DNS because you're using the open Wi-Fi here at MIT, and I set up an access point and I send my own DHCP server and I say use my DNS server and I say no, Google is my local address. When you put your browser up to that Google.com, you may be getting my IP with my fake Google.com cert, but it will not be signed by a root certificate which is in the trust store of the browser of the device that you have. Now, hopefully when you get that error message in your browser, you say, get me away from here. Not everyone does, but but hopefully you're going to that to that site and you're seeing an error that that looks like this in your browser, that says, wait a second, this site is not actually trusted, and you shouldn't be accepting it, right? You should be clicking the back to safety button, right, in Chrome or whatever it shows up in your browser. You'll see this not secure. You'll see all of the this error message and say, error cert authority invalid, and it'll tell you why, right? And so that hopefully answers the question, right? Of how can we say that all of these pieces work together? It's like, how does anything work on the internet? It's because a bunch of folks got together over some beer and pizza, agreed to a standard, and we also sort of benefit from that, right? There's no beer and pizza at CAB forum meetings, unfortunately, but such as how it goes. But we're glad that there is such a thing as the CAB forum.
It's just sushi and wine spritzers, right?
That is right.
But the number of root authorities that are loosely affiliated with intelligence agencies is large.
Yes. Some of the root certs that you saw on the default trust door on Mac OS or Android or Windows or even Linux are questionable. The industry has been moving towards cleaning that up, let's say. And so that brings us to the next topic. What's going on between Google and Symantec? Google being one of the largest presence of TLS on the internet, definitely by far some of the largest percentage of TLS clients that we see out there. Google Chrome is the biggest one. All the Android browsers are effectively Google clients. And Symantec being largest by volume, second largest by volume certificate authority that's out there. I believe Komodo is number one. Symantec is number two. But definitely by far some of the broadest range of certificates. Google has taken issue with some of Symantec's issuance practices, or lack thereof, and lack of appropriate validation on some of these certificates that were issued. There's been a sort of history of misissuance by Symantec and their subsidiaries. Mozilla has a great page, you can search for it, that lists these, that have sort of kept track of these types of things. Where certificates were issued in violation of the baseline requirements and not following the validation. So Google has been out to fix this for the benefit of the whole internet. And one of the big things they're doing is pushing Symantec to change their entire PKI infrastructure and processes out to clean up the issuance. They're doing this by, not through CAB forum, unfortunately, but by distrusting certificates issued by the Symantec roots. So this is a big deal, right? Many companies use Symantec. Akamai Symantec is a strategic partner of Akamai, and so we have tens of thousands of certs issued by Symantec on our network for our customers. And so there's an entire process going on of moving off of the existing Symantec infrastructure onto new infrastructure that will hopefully be more in line with the CAB forum rules and with validation, with the validation requirements. And so when you look at how this process happens, there are groups that are powerful enough to push certificate authorities into behaving correctly. Sometimes it happens that a certificate authority misbehaves not through I was about to say not through any fault of their own, but I was going to use DigiNotar as the example, but I say that's actually their fault for not maintaining their infrastructure in a secure environment, a secure method. DigiNotar was a certificate authority that was hacked very badly, and their keys were stolen. Certificates for sites such as gmail.com and google.com were issued by the hackers, although I don't know if it was ever proven, but they were used in Iran. They were used to sniff traffic for various political groups in Iran, and it led to some very bad things happening to these folks.
So rather than no fault of their own, it would be more accurate to say it's not through malice, but rather through negligence.
That is correct. Yes, let's put it that way.
And if you're a certificate authority, negligence amounts to fraud. So the distinction between malice and negligence with DigiNotar is meaningless.
Yeah.
Well, it's like the difference between evil and incompetence. They both have bad effects, but
No, if you're
come from different
if
places.
you're claiming to be a notarizer of other people's security, willful negligence, it is a serious problem.
I'm not disputing that. I'm just saying they come from different places.
Yes. The net effect of the DigiNotar hack is they were forced out of business.
And this is a good thing.
And that's a good thing.
We need quite a few more corporate death penalties.
Right. So,
but I'm just, I find it highly unlikely that there was nobody at DigiNotar that understood that they were being idiots, and therefore it was willfulness by somebody who preferred profit over competence to ignore the people who warned them. Maybe they laid them off such they stopped warning them, but that is willful negligence, and that's.
I agree with you. The consequences that came out of it were the right, were a good thing to see, and I think the consequences of what's coming out of Symantec is also good because we will wind up with a cleaner PKI in internet infrastructure after all is said and done. And this again is why it's important to maintain your TLS clients and servers, right? Because you will need to update to the new Symantec routes because your client will start encountering them on the internet as you connect to various sites. And so it's important to have an updated trust store that has the new routes in them. Right? There's various ways that they're going to cross-sign.
The old ones.
They're going to do cross-signing in such a way. I won't get into the details. There's ways of handling that transition through late next year as the transition continues. But yes, to get rid of old ones that are no longer secure, no longer acceptable. Let's talk about some of the advances that are going on in the crypto side of TLS. Ecdsa is one that we're seeing come up. I'll bring up a page from Cloudflare, another CDN that's out there that talks about Ecdsa. So for decades, the primary method of securing the connections in TLS were to use RSA certificates, right? So RSA is public key cryptography generated where the public key is a factor, is the result of multiplying two prime numbers, and then something else, and then the private key is also in there. But there's RSA key generation. You can read about how public-private key works. But RSA key generation has been used and is used for many, many things out there on the internet. And so when you go to a site and you look at a site and you see the certificate is an RSA certificate, that is telling you that's the actual method of generating what the key actually is. And then there's the signature on that certificate, right? So a individual, the end entity, me in this case, generated a certificate. That certificate has a key. In this case, it's a 2K RSA key. That certificate is then sent off to the certificate authority to be signed, where they say, yes, the person asking for this certificate is authorized. They will sign it, and they will send the signed certificate back. The signature, in this case, is also using RSA. And I will just say that those are two separate things, right? So you can actually have an RSA key in your cert that is signed with an ECC intermediate, and vice versa. There's ways to do that. Generally, they're the same across the full trust chain, but there's ways to do that. So RSA is still secure as far as we know. There's been no public ways of breaking 2K RSA keys in any reasonable amount of time. But it is important that your certs are issued with a finite validity. So Let's Encrypt certs are 90 days. Most OV certs are 1 year or 2 year. Most EV certs are 2 year or 3 year certs.
When you're generating new certificates, is there any reason not to just go with 4096-bit?
There is, yes. The reason being is the larger your RSA key is, the longer it takes to encrypt the data going back and forth. And so you'll actually slow down the handshake and the connection, right? It uses more CPU. And of course, as we know, these are exponents. So it's not double the amount, it's 2 to the, it's way more. So for root certificates today, the guidelines is, yes, generate a 4K key, right? Because the root certificate is not used for the TLS handshakes. It's used for just validating the certificate chain or checking that trust chain. And even then, you'll typically have a 4K root with a 2K intermediate and a 2K leaf cert, right? Mm-hmm. And so you can do that, but and establish those TLS connections. But if you have a 4K leaf cert, then you need to use that key, the private key on the server, for generating the session keys for handling the traffic. And that is slow. I mean, CPUs are plenty fast, even with some things that are out there, but it's still going to be slow.
I thought the 2K key was good for 5 years, and the 4K key was I think it was projected 10 years. Is that right?
So it's a
2
question
years ago.
of it's a question. What you're seeing is how long would it take to factor a 2K or 4K RSA key?
Yeah.
Right. So if you have the public key and you want to get the private key, that is effectively fake the certificate. If you had a 2K key, how long would it take to factor that using
currently they say
current technology? It's about 5 years. It's something along those lines.
So a certificate shouldn't be, as he said 2 years ago, that was the case. Mm-hmm. So a certificate for 3 years is not in great shape.
That's right, and I will tell you that's why I use where I have the choice. I use Let's Encrypt, which are 90-day certs. Where I don't have the choice of Let's Encrypt, I will not use more than a 1-year certificate for exactly that reason. Right? Okay. I don't want that cert to be out there for that long.
Sometimes the fastest way to factor is wait for the factory technology to get better.
That's right. That's right. Or throw more money at the problem. Right.
No, well, there's somebody doing that.
There are people doing that.
Something like state actors.
No, none of them acknowledge it, but we presume that's the case.
No such agency.
Yeah, and so I would not do more than 1-year certs. For EV, there's reasons people do 2-year certs because it takes a long time to get it. But even for EV, I would ask for 1-year certs personally. Like I would put the operational procedures in place to make sure you can get those certs renewed. And in fact, that's why Let's Encrypt pushes 90-day certs. That's why the industry is moving to shorter lifetime certs, because it forces operators, site operators, to depend on to implement automation for certificate operations. Right? You don't want your key rotations to be a manual process, because that's where things go wrong, or people don't want to do them, or they wait till the last minute. You want it to be an automated process.
But EV certs require 3-level
right.
identification of.
Right, and so there's
such
reasons for that. It takes a
isn't
long
possible.
time. Right, and sometimes an EV cert might take you 4 months to get, just physically to go through the validation steps. And so a 1-year EV cert becomes really onerous, right? And so there's reasons, okay, maybe on an EV.
Start replacing it as soon as you get it.
Right, effectively.
Well, I think you start replacing it halfway through, but.
Well, the usual problem is they lay off and fire the guys who created them.
And they don't even know they have it.
Yeah, and they don't even know they have a procedure. So.
They don't know that.
And the reminder to start now is going to an email that doesn't exist.
Right.
Yep.
Or it still exists, but nobody's reading it anymore.
Yeah.
That's
and so this is why you want automation for these types of.
So what's the downside for if you're just running your own web server or something for switching your certificates every week or something?
If something goes wrong, you're on vacation, you left your SSH keys at home, and your cron job fails. Guess what happens? Your cert expires, right? So you have to pick a validity period that allows you to go on vacation without your SSH keys.
But something like Caddy would do that.
And Caddy would do that automatically, right? And so that's why there are 90-day certs. This is why Let's Encrypt, for example, does 90-day certs and allows you to renew them 60 days into the 90-day period. So you have 30 days to fix it if something goes wrong with your automation or with your validation or your DNS or whatever.
Well, they're unimaginative. I mean, you might want to go on a 1-month vacation, and that's too short.
So does the popular brands of demuxing concentrators support Caddy?
You mean like
F5?
load balancers and
Load
such?
balancers.
No,
like
they are their own TLS servers and clients, right?
Yeah, okay,
so
but
you don't run a web server on an F5. F5 is the web server effectively, and it has its own built-in. The question you may want to ask is, does the F5 support the Acme protocol to get certs from Let's Encrypt? I don't know the answer to that. Because what you want is that the server that is terminating the TLS connection is where the key and the cert need to be, and that's how you need to think about the automation in the infrastructure. Again, on my box, I don't run Caddy, right? And so I don't have that advantage. But I run a Let's Encrypt client called CertBot. It's the authoritative client. There's many others out there. If you don't like it, you can pick from a whole list. And you can, I have it set up in a cron job, and it renews the certs as necessary. But, and we can talk some about Let's Encrypt it. Let's jump to that, and we can skip Ecdsa for now.
With Caddy, when you replace the certificate, can you have the server pick it up immediately without having to restart the service?
It does it automatically. I don't know exactly how. I mean, it does it in a way that gracefully restarts it, so it doesn't drop existing connections, right? And again, that's the importance of renewing your certs with enough overlap where you know, okay, if you have long-lived TLS connections, let's say most browser to web server TLS connections keep alive for not more than an hour, let's say. So you have plenty of time to, if you renew it a week early, then you're going to be fine there. But Caddy and others will automatically, or will pick those up. It's designed to pick that up automatically. Whereas, for example, Apache or Nginx, you do have to do at least a reload, I believe, for it to pick up the certs.
So with Caddy, when it puts the new certificate in, I'm just thinking, I don't want to pay attention to this. What's the sort of like downtime? Or basically, if somebody's using with an old certificate, they're just not going to be able to access it until they reload their page in the browser, or what's the?
I don't think you will have any downtime, right? So if a web browser connects to a server,
Caddy server.
let's say it's Caddy, right? And it establishes the TLS connection, so the cert is valid, and it has a keep alive. And in the middle of that keep alive time, let's say the keep alive time is 1 hour. You know, 30 minutes into that hour, that cert expires because certs are valid down to the second, right? Hopefully, but you shouldn't ever be in that state, right? First of all, because you should never replace the cert the second it expires. You should replace the cert a week prior to it expiring. So you should never be in the state where the cert is expiring in the middle of an active TLS connection that's already.
Okay, but if you are.
But let's say you are, right? Then what the server will do is it'll go off and get a new cert and then install it. But it won't drop the existing. It shouldn't drop the existing connection because the existing connection is. The cert is used to establish the connection. It's not used during the connection, right? So the cert is used to authenticate the validity, the identity of the server to the client. Then they negotiate a session key. That session key is used for the duration of the TLS transaction. And then if that TLS transaction drops because you didn't click around the web page and refresh the keep alive, and then it comes to establish a new TLS connection, it would see the new cert at that time.
Well, that assumes that the session key expires, and then the top level key to create the session key doesn't need the cert.
That would be the new cert, right? So
assuming it would automatically grab it. Sometimes they mess up in that implementation.
Right. So Caddy has shown that that's one of their design flaws.
This usually happens when you're doing telemetry data real time over the network.
Yeah.
That runs for weeks, months at a time.
Right.
You know, seismographic data or something.
Yeah, that's right. So you need.
I would think if the server is restarting, then any session key is automatically invalid after it restarts. So then it would have to renegotiate anyway.
It depends on the server. A lot of servers will maintain a session cache of those things, either memcache or hopefully not on disk, but in other places to support that. And it depends. Again, it depends on the sort of scale that you're running at and how you want to set. You can set up your servers in various ways. I think, like for example, the F5, like the load balancers, the hardware load balancers, will have a mechanism for doing this, and then you can have hot failover to another, and they'll pass the session keys across. But let's talk about Let's Encrypt. Let's jump to this because I think that there's a lot of interest in the TLS world and a lot of excitement for that matter. So Let's Encrypt is a certificate authority, like any other certificate authority. You can make a request to them to get a certificate. They will validate that you are authorized to get that certificate. They will generate, sign your CSR, your certificate signing request, sign it and send it back to you. You can put it on your website. So it functions just like any other certificate authority in that fashion. They generate TLS certificates. They are different from the other certificate authority, the large CAs such as Komodo, Symantec, DigiCert, Entrust, GlobalSign, in that they only do DV certs, they only do domain validated certificates. They are publicly funded, so they are not-for-profit corporation. They are funded by donations from the vendors you see listed there. Full disclosure, Akamai is a vendor, is a sponsor of the Let's Encrypt organization, and I helped actually establish that relationship and that sponsorship. Was on the team that got that going. And Akamai is a large user of Let's Encrypt certificates. Another major difference between Let's Encrypt and some others is that they are trying to be fully automated. So there's no one at Let's Encrypt you can call. They have no phone number that you can pick up the phone and say, I want to get my cert, I'm having issues, how do I get it validated, why are you not validating it? There's no one at Let's Encrypt you can call to get support for how do I install my cert, why does this browser not trust it, what's going on. There's no one at Let's Encrypt you can call when their systems are down, which has happened on occasion. You just sort of have to
And so they're really trying to be very different from other certificate authorities. And the thing to take away from this is not just that, okay, it's made all of our lives easier for setting up a TLS server, and there's, again, no reason you should not have a TLS server on the public internet over a non-secure server today. The real push, the real thing that's come out of Let's Encrypt and the real change in the industry because of what they've been doing is that it's driving the industry to think of TLS like we think of TCP, like we think of IPv4, and hopefully soon IPv6.
Party like it's 1999.
That's right. It's driving us to think about TLS as something that just is always in place for traffic on the internet. Right? It used to be really hard to get a cert. You had to file all this paperwork. You had to call up people. You had to fax stuff with an analog fax machine. You had to throw money at the certificate authorities to get certs. In fact, you still can. They will gladly take it. But you no longer have to do that. And this is what Let's Encrypt has done, is change the industry from thinking about TLS and certificate issuance as an expensive problem, as a slow problem, as a hard problem, and moving the industry to thinking of TLS as something that is hopefully as ubiquitous as IP. And we're starting to see some very interesting things around it. The sheer volume of certificates that they're doing. So I'll just walk through it. It may be hard to read some of the labels on this graph. So it's the x-axis stretches from October 2015 to yesterday when I pulled the graphs, so October 2017, so 2 years of data. The lower graph shows the number of certificates issued per day, and you can see they're about at 500,000 certs, maybe 600,000 certs issued per day in October. The upper graph shows you, with the top line on the upper graph, the number of fully qualified domains across all the certificates that are active, that are non-expired, that they've issued, well in excess of 55 million active domains, and just over 40 million active non-expired certificates.
Do you happen to know offhand what events correspond with the big spikes in October, January, and March?
I don't know those specific ones, but I can tell you most of these spikes that you see are when a large hosting provider, such as WordPress.com, flipped on their infrastructure to secure all of their hosted sites. That's typically what happens is they will say they're going to do this, they'll run some tests with Let's Encrypt, and then boom, it looks great, and then just let it run as fast as Let's Encrypt can issue the certs. Right? And the process is another major change that Let's Encrypt has pushed. Prior to Let's Encrypt, if you wanted a certificate, even if it was domain validated, you had to go to a web page, you had to generate a CSR with OpenSSL or some other tool. You take that CSR, you went to a web page, you pasted it in the web page, you click the button, it would say, okay, take these tokens and put them in your DNS, or take these tokens and put it on a web page at this URL. You went and did that on your server or in your DNS, and you went back to them and said, okay, I put the tokens there, go check them. They would check the tokens, hopefully they were all correct in place. Then they would issue the cert, and then email you or present on a web page the signed certificate. You would download it, put it in a file on your web server, configure it, restart the web server. Very manual process. What Let's Encrypt did was they created a protocol for certificate issuance called ACME. The ACME protocol allows that whole process I just described of domain validation to be fully automated, whereby they say that you have to be able to issue those certificates by putting the tokens in, what's the CSR that you want, put the tokens in the right place, and all of that whole process. They've automated that with the ACME protocol. Just bring that up for a second. So what Let's Encrypt does, and with the Acme protocol, is walk you through that process of saying, I'm a web server, so I have a web server, I want to cert for example.com in this case. It sends back this, put this token in the right place. It'll assign the token, you'll send it back, it'll check it, it'll do this whole song and dance behind it. And what the Acme protocol actually does is it automates this so that you can have a client running on your web server that talks to Let's Encrypt as a certificate authority and does all this for you in the right, automatically. So Caddy, as we've been talking about, is a web server that has an Acme client built in. You can run your own Acme client on your own server on whatever server you want. So as I talked about, Let's Encrypt. Apache is getting much better TLS support. This is, as we talked about, it's the configuration that's coming to get you the new SSL policy directive, as they call it. But it's also getting Acme support, right? So it'll be easier in Apache to configure to be a good TLS server, but it's also now easier in Apache to get a certificate installed. It's a module that's coming, and it's called modmd, and you can go poke around with it. But again, if you don't if you don't want to run those, you can go to the Let's Encrypt documentation, click on Acme client implementations. It will tell you use certbot. I recommend that as well. It's very full-featured. It's pretty easy to use. But there's lots of other implementations in various languages, various plugins that are out there to support this protocol. And again, this is sort of the big change. The fact that Let's Encrypt drove the adoption of Acme, which is their own, but the specification's public. The next version of Acme, Acme v2, is going through the IETF process, so it's going to be an industry standard. We've seen other certificate authorities implementing the Acme protocol for certificate issuance. And it's been great, again, to see that growth of certificate issuance and that growth of usage because they've made it so easy. Right? They've made it so easy, and no reason not to do it.
Where does this leave the commercial CAs? Is there any reason to get a domain validation verification cert from a commercial CA? Is their business restricted to EV from here?
There are reasons to continue working with a commercial CA. I'll give you some examples. One is that load balancer example we just talked about. If you want cert automation on your load balancer, and again, I don't know specifically if F5 as a vendor does or does not support it, but for sure there are hardware load balancers that don't support Acme. And so it becomes impractical to run Acme on an Acme client on a separate server and then automate pushing the right pieces in the right place on that box, on that load balancer box. I don't think you want to do that. I think that's too many things that could go wrong.
If my hardware load balancer has a deal with a certain CA, I'm stuck using that CA until I can replace it.
Most hardware load balancers do not have those types of deals. They just have a place to say, paste in the cert, and you can get it from whomever you want. Right?
But basically, these could be considered.
But it's a manual process to upload the cert into the device.
So there's, because it's a manual process to upload the cert in the legacy hardware, you want to use somebody whose certs last longer.
There you go. That's right.
That's a failure of the hardware vendor to not provide.
As I said, that's one example. That's one example. I'll give you another another example that we've seen.
Think of it as electronic buggy whips.
Yeah.
We have seen at Akamai, but just in the TLS industry, we've seen vendors who want to pin certificates. So we talked earlier about how Google Chrome ships with signatures of valid Google certificates in the actual browser. So if you have a legit copy of Google Chrome that you downloaded securely and you run it, and it connects to a site called gmail.com, it doesn't actually validate the certificate for gmail.com using the standard, oh, is it signed by a trusted root? It actually has a signature of that exact certificate that it expects to see for gmail.com. It's actually multiple ones because there are multiple servers and they handle rollover and various things in the browser itself. This came out after the DigiNotar hack and that the example I talked about of what happened in Iran, when it was realized, oh, we need to be a little more sophisticated about this. So some vendors will have TLS clients. This happens a lot in the mobile world. So for example, the bank that I use has a mobile app that I run on my iPhone. And in that app are the hashes of the certificates that run on the server that it expects to taunt. Now this is very interesting because what it does is it gets around the problem of TLS interception, TLS middle boxes that may be generating a certificate on the fly for sites that you go to. Antivirus on Windows generally tends to do that also, generates certs on the fly as you go through a chain to its own root that's already in there. And then either intercept the traffic or inject things into the traffic. It also gets around the problem of what's called the the captive portal, right? So if you fire up your device on a hotel Wi-Fi or an airplane Wi-Fi or something like that, where you are presented with a captive portal, sometimes you don't want, and your browser is set to go to www.bank.com. You may not want to leak the fact that you're going to that site to the vendor of the captive portal. You may just not trust them for various reasons. And having that PIN cert allows the client to say, oh, wait a second, this is not the cert I'm expecting, so don't try and make a connection. And so in the case of pinning, and here's the story, and here's why you should not use Let's Encrypt for mobile applications that pin. Well, let's say you do your cert rotation, or you have a planned cert rotation. So you know, and you have the private key and the cert you're going to rotate in, the new key and cert, and you hash that. And now you want to put that into your mobile app. Well, that's great, but now you have to put it in your mobile app. You have to do a build of your mobile app, which hopefully not going to take more than 30 minutes or so. But depending on your corporate process, there may be QA involved, there may be build times, there may be shipping it. You have to send it off to the department that submits it to the App Store. Then you have to submit it to the App Store, which is a whole other problem. If you ever run Xcode, you may learn that this is a problem. Then you have to wait for Apple to approve it. And whether that is a good thing or not for debating tonight. But that could take days or weeks. Then you have to wait for that new version to be rolled out to a significant portion of your population of those handsets. Again, that could be an additional set of weeks. And so now you're well into the 90 days that the cert that you have sitting here that you haven't deployed yet is actually going to.
What happened?
Does it have a clock?
You're well into the 90 days of.
Oh, we've never been here this late.
Yeah, it's coming back up. So you're well into that time, and so you can't actually deploy the new cert, or you're forced to deploy the new cert because the old one's expiring, but your handsets have not been updated with the new version of the mobile app because it's waiting an App Store review or it hasn't been taken up, right? So in those kinds of cases where you have a fixed known TLS client and you have a a process that doesn't allow you to operate at that agility of that 90-day window, an OV cert makes a lot of sense. There's a last example I will give, but if I was standing here in February, I wouldn't be giving you this example. and that is wildcard certificates. So a DV cert from Let's Encrypt is limited to 100 names on an individual cert, and then the certificate can only match those particular names. But sometimes you may want to have multiple names that all match a standard domain. So star.example.com. Maybe you're a hosting provider, or you just want to give every user1.example.com, user2.example.com their own host names, and you don't have to update the server config every time. So you can do wildcards with virtual name matching. Let's Encrypt does not currently offer wildcard DV certificates, but they will be doing that early next year. So those are some examples. If you want the green bar in your browser, you still need an EV cert. To answer your other question of what are the CA vendors going to do, we think in the TLS industry that the growth is all going to be in DV certs. There's not going to be growth in the other type of certificates. There's still reasons to get them. But again, this is, I think, a good thing.
Did you say the growth is going to be in DV certs?
In DV certs.
Okay,
That's right.
you did not misspeak and mean EVs.
No, the growth is going to be in DV certs.
Because that's what's going to replace.
Because that's
HTTP.
what's easy to get,
Yeah.
right? It's what Let's Encrypt is pushing. It's what if you set up a site again, you run Caddy Server, you get a DV cert, right? It's
When you say the growth will be, and you mean the count of certs.
count of certs. Yes, I'm sorry.
The dollar value growth is all going to be in value added certs, either supporting obsolescent hardware
Yeah.
or turn your browser green.
Yeah, EV certs.
That's right.
Yeah.
Yeah.
Okay.
No, you said dollar growth. I mean, the dollars might shrink because people will be moving off of paid certs onto free certs.
Yeah, that was my initial
Yeah.
question.
Yeah.
That's right.
Any growth would have to be in the value added ones
Yeah.
because
Yeah.
There's other cases that we've seen that I think will continue that Let's Encrypt is not going to support. I'll give you an example. Again, if you're a large enterprise company and you have multiple servers or multiple, even if you're not using a CDN like Akamai, you're just hosting it on your own infrastructure, you may not want to install a Let's Encrypt client on every public-facing internet server and then monitor that and make sure that's all working. And there's a lot going on there. And so the vendors, the large certificate authority vendors, offer APIs for centralized management. They offer, enterprise relationships,
Security as a service.
security as a service, all sorts of other, again, value-add services. So I think there's still a market for that. It's going to continue, and we're going to see those, those vendors still being able to offer that support. And and we'll see demand, and not just for EV, but for OV certs, right? These vendors, there's still a demand from large corporations that are not looking to move to a free, community-supported certificate authority like Let's Encrypt. If you're running a large business, you may have questions or doubts about that, about basing your infrastructure on something like that.
you're leading to my next question.
Yeah.
Is there a security downside to pushing automated registration and certificates? This is basically allowing a web server to certify that its name is whatever DNS says its name is today.
Yeah.
So we're promoting attacks at on the DNS system that we already know is thoroughly flawed.
If an attacker has access to your domain, you're screwed, right? So does it matter that they can get a cert for that domain? They can redirect your www traffic anyway to their own server, so what does it matter?
At that point, you just need to nuke it from outer space.
Again, this is one of the things that Let's Encrypt has pushed, and it's a good thing you asked that question. But what I'm trying to highlight here is they're moving the industry from this is an extra thing to do, this is a hard thing to do, this is an expensive thing to do, this is a slow thing to do, to no, it's just part of IP. Like, you don't ask about IP anymore, right? You just get it. I mean, granted, if you want IPv4 addresses in North America, okay, putting that aside, like it's not something you think about. It's like, okay, we I don't want to say take it for granted, but it's just assume that you're building something on the internet, you're going to have IP
I guess I'm asking if we...
TLS should work.
If we force everybody to use TLS, but make TLS no more secure than DNS, while we are protecting privacy when you're actually connecting to who you think you're connecting from eavesdroppers,
yeah.
Are we possibly making things a little worse by pretending to the public that DNS is better than it is, by giving them a nice little padlock that says, we certify that we think you're connected to who you think you're connected to, even though we have no right to think that.
So,
are you aware of DNSSEC?
Are you aware of anybody that implements it at scale?
There is
I'm aware that DNSSEC has been proposed.
These are questions. DNSSEC, Dane is another one that's come around.
The nice thing about standards, there's so many to choose from.
The one I will point out that is an accepted one is called certificate transparency. This is again, it went through the CA browser forum, the KEB forum, and is going to be, if not already, required. I don't think it is required, but again, pushed by Google because they're addressing these types of issues, right? Because they see that. Certificate transparency doesn't help in that instant where you're connecting to someone who's fraudulently obtained a certificate, but as an operator, you should be monitoring certificate transparency logs for your domain. So let me tell you how this works. Any certificate authority that is following baseline requirements that's approved will, when they issue a cert, send it into the certificate transparency logs. These are public, they're out there, you can query them. There's a great site that Komodo runs called Certificate Search. You can come in here, you can type in whatever you want, search by common name, search by issuer. It's every cert that's been issued in the last year and a half, and going forward, it's now a requirement that every CAB forum compliant certificate authority logs their certs to a CT log, and the browsers check that when you're connecting, that the cert is logged in a CT log. It doesn't have to make an extra connection. There's ways of doing it without. But this is the thing: is as a owner of domains, for example, I have a search set up on multiple vendors, multiple sites, and that checks the CT logs daily for certs issued for my domains, and I get a report. And if I see something that's not right, then I have, hopefully if I still have control over my DNS, a way to go and revoke that certificate and tell that CA that I didn't ask for this, I didn't issue it. What happens after that? Again, separate topic and time.
And that's a way.
But it's a start, right? It's a start.
And that's a way that if your two arms of your company aren't talking to each other, somebody could break something that somebody else was rolling out intentionally. Yeah.
Yes, that's right. So and we've heard of those types of stories that happen.
But that still only protects you from CAs that are doing things correctly, which is not where bad actors are going to go.
But if a bad actor,
an APT actor is going to go to like the Hong Kong post office and tell them, by the way, do not put this on transparency, and they're going to say, yes, Mr. Commissar.
That's right. But again, it's that the root cert of that CA is not in the trusted browser store because they're not CAB forum compliant.
Are you saying that?
I'm saying that any vendor, any CA that claims to be CAB forum compliant must submit all the certs issued to CT logs, and all the browser vendors are saying that if they haven't already, they will very soon, only accept certs from CAB forum compliant roots.
Well, you can say you're forum compliant and submit 98% of them.
So then,
but not the one that you send over to the Chinese cyber war department.
This is not a perfect system. I don't claim it to be, but I'll say that.
And then there's the other matter of the ones that your corporate firewall creates on the fly that the pinning is detecting. Those aren't going to appear in transparency because they're not CAB forum, but they were injected into the browser by corporate IT before they installed it.
That's right. And so there are ways to turn off CT checking in browsers if you really want to. I would not recommend it. There are ways of putting your own root.
There's
there's all sorts of things around this. Private CAs.
This is.
But I think it's interesting to explore the failure modes, but all of the failure modes that are generally discussed, and I don't mean to stop it, the discussion. I think it's great that you're thinking about it, but all the failure modes start from the premise of, well, someone got a cert, assuming the CA was not hacked, that means your DNS is hacked. And again, if your DNS is hacked, you have way bigger problems than someone fraudulently issuing certs in your name. That's where
DNS is hacked regularly by coffee shops, hotels,
yes,
employers, universities.
Right, but TLS is not aiming to solve those kinds of things, right?
Hmm?
It's not going to solve the DNS problem. TLS is not going to solve the DNS problem. TLS is about authenticating who's at the other end and encrypting the data.
Assuming we live in a DNS system that does what it says on the tin is a false assumption.
Agreed. And there are things
Verizon
coming.
Does not report an error and redirects you to their web page.
That's right. There are things coming in the TLS world to address these types of things.
Good.
So DNSSEC is one that we'll see where that.
It's been
coming for a while.
It's been coming for as long as Perl 6.
I'll give you another example.
Perl 6 is working.
This came up recently where someone proposed the possible attack against CA, where if you could hijack the connection between the CA and the DNS servers they are using, then you could put in whatever you want, right? And so the mitigation that is now being discussed in the CAB forum and by vendors is that CAs should do, I forget the exact term, but they should check the DNS record from multiple network paths to either to the same server, because again, you may only have 2 DNS servers, but they should not rely on a single network path between their validation servers and the DNS servers that contain either the token or the IP addresses of the web server to go look at the token. And they should do both those validations through multiple paths. I think that's fascinating, and I think that's, again, the industry talking about these kinds of things and trying to address these kinds of things. By all means, we are way better off today than we were even just 2 years ago, right? You look at the growth of TLS traffic on the network.
Right.
It's 30%, it's 50%, wherever you measure it, it's huge, and it's growing. And there's a lot of stuff coming out there to make it to make it easier for everyone.
I remain concerned about how somebody that's on a network where the firewall may be redirecting DNS and redirecting connections and making up certs on the fly.
Yep.
And they've, since corporate issues your
That's right. Your laptop, you're good.
Your laptop, it's got the root certs they want it to have. But you see the
Yeah, you see the lock.
Green or gold or whatever bar and lock.
But I will argue in that case.
You're talking to your bank.
But you're not.
And you're actually talking to.
Yeah, TLS middle box sitting in your employer's data center. But I will argue that in that case, the attacker is your employer.
Absolutely.
And you're working on untrusted hardware. You shouldn't be accessing your bank.
But if we're and it's are pushing TLS everywhere and telling people that it's safe with the nice little lock everywhere and not just it.
I see where you're going. So there's a recent there's a discussion that has come up again after Let's Encrypt really pushed the industry in this direction of for 12 years, 15 years, whatever it is, that SSL and that the lock has been there. The lock has meant to users, maybe not users in this room, but users in general, to mean that the site I'm going to is secure. But
which it absolutely does.
Which it, right? What it really has meant is that the connection between your browser and the site is secure.
Yeah.
And there are some great researchers at Google who are looking at this. It's the usability of security. How do we move that perception from one to the other? I don't think there's a good answer yet.
I'm going to assume the compliance firewall at corporate is capable of generating a fake EV cert instantly because it doesn't care about all the hoops that have to be punched for an EV cert.
Not if you're using Chrome, but
yes.
or Safari.
Well, no,
you can generate an OV or a DV cert.
Google.
You can anyone. The EV as an example has extra validation that's shipped in the browser. So as long as you're not building your browser from scratch. But a DV cert
how is Chrome going to tell that a non-Google EV cert is fraudulent? If the operating system, does it ignore the operating system roots?
So in Google Chrome, shipped in Chrome, is a list of what are called OIDs that are in the X509 data structure that indicate that a certain certificate is allowed to be marked as EV. Effectively, that's the flag. In the certificate, there's an OID that says this is an EV cert, and then the browser displays the EV bar. There's nothing else, right, because the encryption is all the same. But there is a list of those OIDs in there, and those are tied to specific root certificates. So you can't, it's not the same, it's not shared, right? So if your corporate middle box is intercepting and generating the cert on the fly, and it won't have an OID that is in the binary of Chrome.
So effectively, Chrome has a list of not certs, but
attributes it expects to see in the certs.
Secure values it expects
That's
to
right.
see and there's some non-forgeability there with the OIDs.
Yeah. Again, DV and OV, so there's all sorts of ways around it. EV has that extra, which is why some the banks still, financial institutions still like it.
Yeah.
And
if we can train people that the bar has to go green before they spend money, that would be good.
Right.
But we've pushed the gold lock so much that the green bar is
An afterthought?
going to take another 10 years.
Yeah.
It's going to take a while.
By that time, Emperor Trump.
So at least for EVs, they're providing something like pinning for everybody. Is there any pinning? Is there anything like pinning for people that don't
control the client?
There's a standard called HPKP, and
Maybe that's what I was thinking.
yeah, you get it's sort of pin-on first connection. So you as a server operator can put the hash of the certs you use in a HTTP response header that you send back to the client, and then the client it has a hash of one or more keys. I would recommend more than one, so you have the possibility of cert rotations in case your keys get lost, and a TTL of how long it should see that, and then you can put that in as a response header, and then
and you base TTL based on how often you expect people to come back to visit.
Yeah, that's right. But there are serious flaws in HPKP. There's an attack that's been talked about. Imagine an attacker hijacks your DNS or something, your site, and puts an HPKP header with a TTL of 10 years with their own cert key or hash in it. And your users go to that, they'll see it, the browser will see it, it'll save it, and then even if you recover from the hack, you're screwed because those users know.
That hack could be done by injecting it into somebody that provides the welcome page. Click here
There you go.
for
That's
internet
right.
access at pizza and chicken shops or hotels
That's
or
right.
something.
And so to get around that, there's a second header called HSTS, which basically says to the clients connecting, when you connect to this site, it should always be HTTPS. Again, it's on first use, so you could make an HTTP connection, send back the HSTS header, and then any new connections are all HTTPS only. But once you do that, you can then submit your site to what's called the HSTS preload lists, which gets shoved out to the popular browsers every month or so, to prevent even that first use. So there's ways around it, and there's, again, lots of things to think about.
Close anymore. If somebody gets control of the people managing the click here for internet access points in a food chain,
Yep.
they can do an awful lot of dirty.
Yes.
Because they do control the DNS.
That's right. That's right. There's a lot of ways this could go bad.
We should probably start to wrap things up now.
Yep. I had a few other topics, but I think we covered a lot, and the questions have been great. Thank you. I always learn stuff when I come to these meetings. Happy to answer some more, and if you had specific questions, you can always email me. I will send the link to the webpage that has all the links, or many of the links we talked about, to Jabber, or maybe just to the discuss list, and you can find a lot of those links there. And again, if you have any questions, happy to answer them. Great, thank you.